So what exactly does the strategy design pattern do for you? Well, here's the problem it's designed to solve. So you have a class, a base class. It has a method in it called doTask. It does perform some task, and yet that method is frequently overridden. In other words, it's what you call volatile code. Volatile. And the code has to be changed frequently in the derived classes. For example, here is your base class, and it's being inherited by a second class here, as you see. And this has got its own doTask, and it overrides the code from the base class. So this derived class has a new version of the doTask method, and the doTask method is going to be frequently overridden in derived classes, inherited classes from the base class. And that's the problem that the strategy pattern is meant to overcome. Here again, you have the doTask method is overridden in a derived class. Another class is derived from that derived class, and once again, it's overridden as well. So it's very volatile code. The doTask method, very volatile code, and it changes frequently as you go down in generations of inherited classes. And that's the problem, because when you have inherited classes that write their own overriding code all the time, and you have a very volatile method that has to be replaced all the time in all those inherited classes, you have a maintenance problem, because you have to then, if you want to make any changes, you have to make changes over many generations of inherited classes. So that's a problem. That's an issue that the strategy design pattern was designed to fix. The problem is that you are spreading your code and your code maintenance problems over many generations of inherited classes. The strategy design pattern says that instead you should have your code with an algorithm variable. This algorithm variable is changed for using different algorithms for the various problems you face: algorithm object 1, algorithm object 2, algorithm object 3, algorithm object 4. So these algorithms are what are placed in the algorithm variable, and that allows you to run different code depending on the object you're working with, the object you are going to be inheriting from. And the idea is you separate out your volatile code from your class into algorithm objects, and you allow your algorithm objects to be different, and you use various algorithm objects inside your code in the algorithm variable, and that lets you supply different versions of the doTask method that use different algorithms. So in other words, once again, what you do is you have taken your volatile code out, put them into different algorithms. These are the different versions of the doTask method, for example. And then you can, using polymorphism, you can plug them into the algorithm variable like this, as you see there. And so you have these different algorithm objects that handle the different doTask implementations, and they are then stored in this algorithm variable. So in other words, you have been able to separate out the volatile parts of your code into algorithm objects like this. That's what the strategy design pattern tells you to do, rather than have a situation where you have a lot of overriding code from different generations of inherited classes. And in this sense, this is a different way of looking at object-oriented programming as far as inheritance goes. This is what's called has-a inheritance, has-a object-oriented programming. This variable allows your class to have an object of the first algorithm and then an object of the second algorithm and so forth. So you have a has-a algorithm object corresponding to the first algorithm, the second algorithm, and so forth, and your enclosing code doesn't change. It just has a algorithm object 1, algorithm object 2, algorithm object 3, whereas here this relationship is inheritance. It's called is-a. So this class is a same type as the base class with added on methods, for example, when you inherit them. But this is a base class type, and this is a derived type plus the base class type. You can use polymorphism in a case like this. So this is an is-a relationship. This class is a base class type. And this is suggesting that if you have volatile code, you separate it out and put it into a has a relationship instead. So your code doesn't have to change as much. Instead, you has a, as it's called, different objects, different algorithm objects. We're going to see how this works in the implementation of your code coming up next.